Hi, I'm Jason Steer. It's been a while since my last YouTube video and I've been feeling a bit guilty about that, so I thought I'd put together a short tutorial on how to speak binary. I know it might sound like a bit of a strange topic, but I'm sure this will benefit a few people and enlighten some others, as well as give you the opportunity to go up to your IT geek friends and tell them that you've just learnt how to speak binary. So let's get straight to it. This is what you would know as a computer keyboard. I also call it a gateway. I call it this because it is the gateway between a human and a computer. We use it to communicate our instructional desires to the computer. At the end of the day, I can't speak computer and the computer can't speak English. But with the help of the keyboard, or the gateway as I like to call it, we have a ready-made translation tool that will help humans and computers to understand each other. Before I go on, you may ask, what is binary? Basically, binary is another word for machine code. Hold on, Jace, what is machine code? Well, machine code is a series of zeros and ones. In fact, you use the basics of machine code every day without even realizing it. Do you recognize this symbol? It's an on-and-off switch. You may have seen one like this on your TV, radio, stereo, tumble dryer, washing machine, etc. What it's actually showing you is a 1 and a 0 for on or off. Or another way to put it is yes or no, or even another way would be positive or negative. This is where machine code started. Zeros and ones are what computers understand. Many moons ago, in the 1950s, computer engineers used to communicate with computers with a series of ones and zeros, which was very time-consuming and difficult. For example, if I wanted to say hello world to the computer for it to understand, I would need to input the following machine code. That's ridiculous, right? So in the 1960s, ASCII was invented, which stands for American Standard Code for Information Interchange. What this meant was that the good old keyboard here had a number value assigned to every keystroke. Let's look at the Esky Roadmap for a moment. As you can see, every keystroke has a value assigned to it, whether it's a capital or lowercase letter, a number, a symbol, spacebars, etc. This is our basis of translation between human input and computer understanding. Let me show you. If I were to type a short name on my keyboard, let's say Tom, when I press the T key here, we have an ASCII value assigned to the key, which is 116. In turn, this value gets translated to the binary format the computer understands. If I type O and then M, we can see that the ASCII values for O are 111 and the M is 109. So the binary translation of the word Tom is 011101000. Well, you get the gist anyway. As you'll agree, it's a bit of a mouthful for such a short word. Thank God the good old Americans invented this ASCII code. I'm sure you'll agree how important it is now. So let's see how we arrive at the binary code from the ASCII value. Imagine that we have a little guy inside the keyboard. He realizes that I've just pressed the T key. The little keyboard guy knows what the ASCII value of T is because he also has a copy of the ASCII Roadmap. I won't go into too much detail here, but I will say that ASCII is an 8-bit code. If we start at 1 and double the numbers every time, i.e. 1 plus 1 equals 2, 2 plus 2 equals 4, 4 plus 4 equals 8, 8 plus 8 equals 16, and so on, we eventually arrive at 128, which is, if you remember, how many ASCII values we had assigned to all the keyboard keys on the ASCII roadmap that we saw earlier. So if I add up all the separate numbers here, we arrive at 8 for 8-bit. Anyway, let's get back to the little keyboard guy. So the little keyboard guy looks at the highest denomination and says to himself, does 128 fit into 116? No, it doesn't. So that's a 0 or a negative or a no, however you want to say it. He then moves on and says, okay, does 64 fit into 116? Yes, it does. So that's a 1 or a positive. And we're left with 52. We then move on and he says, well, does 32 fit into 52? Yes, it does. And we're left with 20. Does 16 fit into 20? Yes, it does, and it leaves us with 4. Does 8 fit into 4? No, it doesn't, so that's a negative or a 0. Does 4 fit into 4? Yes, it does, so that's a positive. And now we're left with nothing. Does 2 fit into nothing? No, it doesn't. Does 1 fit into nothing? No, it doesn't. So that's how we arrive at the binary code for the character T in lowercase. And that's all there is to understanding how binary is worked out. With this information, you can now go away and write your own names in binary or do whatever you want or impress your friends. I hope you found this tutorial useful. Thanks for watching.